And kind of how it works practically is as follows. There's really four steps. It breaks the input text into sentences, and then it takes each of these individual sentences and transforms them into these conceptual embeddings. And these embeddings act like the tokens for the words in a traditional LLM. And these embeddings are then processed and used to generate new concepts. It converts these new concepts back into human readable text. So it's like a code for ideas. It's really pretty fascinating. What is up, everybody? Welcome to another episode of the AI Marketing Navigator. This is your daily compass in the ever-evolving world of AI marketing. Okay, Navigators, back with another episode bringing you the latest news in artificial intelligence as it relates to marketing. And marketers, today we're going to talk about something a bit more high level, but that will definitely affect the AI technology space as a whole, and therefore will be affecting any of us as AI users in the future. So today we're talking about another new type of AI model, and that was announced by the Meta FAIR team, which is Meta's AI research team essentially, and it is called a large concept model, an LCM, and it represents a pretty significant shift away from how we've come to expect language models to work and how the AI tools that we're using currently generate their output, their language. The traditional language models work by basically predicting the next word, predicting one word or token at a time, but a large concept model operates at a much higher level of reasoning by processing and generating concepts and ideas. Instead of language, in the instance of an LLM, it's concepts. The concepts are the text of a large concept model versus a large language model. So it's processing entire concepts or ideas. So to break it down as simply as possible, just imagine that you're telling a story, and instead of having to think about each word one at a time, guessing the next word when we're telling that story, we can think about the entire concept or the main idea that we want to share. That's how an LCM works versus an LLM. A traditional LLM would generate and tell the story one word at a time, like spot the dog ran outside or something like that. And the LCM thinks about that whole idea at once. Spot the dog ran outside in a sentence and as a concept. In this way, these types of models think and behave much more like human cognition. And in order to do this, the model uses something called Sonar, which is a special embedding space. You can think of it as a virtual space that can handle up to 200 languages in both vocal speech and text formats. Definitely a bit of a technical episode, so make sure to check out the links in the show notes. Do a deep dive if you have any further questions or need to do any more research. But let's talk a little bit about this Sonar technology first and what it does. See if we can spit this one out. It stands for sentence level, multimodal, and language agnostic representations. But essentially, you can think of this as the method by which sentences are broken down and then coded in a way that a machine can understand. And in this case, to take it one step further, that can be text-based or speech-based. And sentences can all be mapped to this distinct space, and then the machine can handle that data and process it, and then communicate it to a user into these 200 supported languages of the model. So it's this Sonar architecture that is the backbone of the LCM. So let's talk a little bit about why LCMs versus LLMs. A big part of it is the multilingual capabilities. There's also improved efficiency, and we'll talk about that in a second. But an LCM versus an LLM shows exceptional generalization across languages, and it outperforms comparably sized large language models or traditional LLMs. So without any additional training, they can work very effectively with multiple languages. The next key benefit of an LCM over an LLM is that efficiency that I mentioned. And an LCM is able to process information much more efficiently, especially when it comes to longer texts. It also uses less computational power than a traditional LLM would. And apparently it can handle complex tasks more effectively. What we've seen in these reasoning models is that the more complex tasks you can solve, the better. And I guess that's pretty obvious as I say it out loud, but as the task complexity increases, the closer and closer we're getting to AGI. Okay, so let's talk a little bit about the training and the specifications of the model. It was initially developed with 1.6 billion parameters and trained on approximately 1.3 trillion tokens, but later that was scaled up significantly, and eventually it was trained on 7 billion parameters and 7.7 trillion tokens of training data. And kind of how it works practically is as follows. There's really four steps. It breaks the input text into sentences, and then it takes each of these individual sentences and transforms them into these conceptual embeddings. And these embeddings act like the tokens for the words in a traditional LLM, And these embeddings are then processed and used to generate new concepts. It converts these new concepts back into human readable text. So it's like a code for ideas. It's really pretty fascinating. And there are just a ton of potential use cases for an LCM, just like there are an LLM, particularly multilingual communication being the main one. Seeing as this model can work across different languages so seamlessly, it could be made extremely valuable for global communication. Of course, the traditional LLM use case of creating content, which is a huge one right now, is also going to be there. And it will be fascinating to see what that content looks like when it's not just predicting the next word, but the next idea. As always, check out the links in the show notes for more information to do a deeper dive yourself on LCMs. We will continue to keep you up to date as this research and concept progresses. And as soon as we see some of the first publicly accessible LCM use, rest assured it will be featured on the show. Okay, that does it for today's episode. If you enjoyed the show or found it useful in any way, please do me a favor and follow on Spotify or subscribe on your podcast platform of choice. A review on top of that would be even more appreciated and is so super helpful to the show. Also, if you are watching on YouTube, make sure to hit that subscribe button and turn on all notifications so you get notified each day when the episode drops. Until then, and as always, thanks for joining me, and remember to stay curious, stay consistent, and keep navigating forward. Bye.